Good afternoon, everyone. Good afternoon, everyone. Hey, perfect. All right. First panel after lunch. I trust everyone took as much dessert as you could possibly handle, so we'll keep this as lively as possible. And speaking of lively, this is intended to be a two-way dialogue. We're going to set it up in a conversational style for this particular panel, and the intent is you're going to be asking questions throughout. So you don't have to wait. We have an hour and 15 minutes for this panel. It sounds like a lot, but I know it's going to go very, very quickly. As it happens, we have well-informed and highly opinionated panelists that you get an opportunity to enjoy, and I think that's an accurate description of everybody who is also sitting in the audience today. So when you take about 100 folks that are all well-informed and very interested in asking questions, that's what we're going to take full advantage of here today. So each one of the panelists, so you get a feel for how this is going to go, is going to provide a self-introduction so they can identify what's most important to them. If I was to guess, I would say for Fernando, it's his burgeoning male model career. For Joel, I'm ultimately thinking he's going to talk about his time in the circus. And then for Tim, I think it's looking at his post-IT career, which is really being a yoga instructor, which is his lifelong dream. So
that's pretty flexible.
See, there you go. So I think that's what you'll probably hear the self-introductions highlight. But I want them to just give you guys their own backgrounds instead of me attempting to paraphrase poorly and probably hitting the wrong notes of it. But suffice to say, you have an excellent panel. So what I'm going to do is just really tee up the issue that we have here, which is to talk about industrial control systems and SCADA as they apply to the context of this conference around cybersecurity. And by way of my own introduction, my name's Jonathan Munkin. I'm the Senior Director of System Resilience at PJM Interconnection. How many folks know who or what PJM Interconnection is? Okay, great. We have a couple zealots in the crowd. That's excellent. We are a regional transmission operator. We're technically the largest grid operator in the world. We cover down on about 20% of the US population, and we operate the world's largest wholesale energy market, about $50 billion a year. So what I do there is really trying to stitch together several different programs around things like physical security, cybersecurity, risk management, business continuity, transmission planning, and a whole host of other exciting things. But for me, the dog that I have in this fight as well is I also moonlight as an Army reservist assigned to the NCIC. So this is definitely something that I enjoy, which is the convergence of my two families, both from the energy industry side and from the military side, to have this conversation. And it's that nexus that really brings us to the nature of this panel here today, which is recognizing that in the spectrum of cyber warfare, what we have is a circumstance where people need to really orient themselves to the fact that whether it's in a physical or cyber nature, the interdependencies between defense critical assets, mission assurance, IT and physical infrastructure, and what happens on the private sector side is inexorably intertwined. It's done so by design. There is a heavy dependence of the military on private sector infrastructure for everything from power, water, telecommunications, everything you need for CONUS-based and non-CONUS-based installations, and understanding that all of the gaps and seams that exist in the delivery of whether it's that electricity or even basic back-end logistics for what's being provided to ensure the mission capabilities of the Department of Defense have a heavy dependence on all of this private infrastructure. So what's making all that cool private infrastructure work? Well, it happens to be closely tied to the subject of this panel today, industrial control systems and SCADA. That's certainly near and dear to my heart from an energy sector perspective, but as I think some of our panelists are going to highlight today, you should be very wary of trying to place a finite boundary on exactly what industrial control systems are, what SCADA means when you're talking about the integration of these systems, and how we can really implement in this type of environment just both offensively and defensively. So private sector theoretically represents the soft underbelly of the Department of Defense when you talk about cyber vulnerabilities. And that's a two-sided coin, which is as we look to conduct offensive operations globally, where is the subject matter expertise that's necessary to really truly make those types of operations effective? So there's plenty of things that we can highlight here to talk about. We're only going to be able to get to, as I said, to about an hour and 15 minutes worth of that type of fun stuff. But what I encourage you to do is look at the mission critical nature of this type of linkage that we're talking about, how industrial control systems and SCADA are uniquely relevant to the DoD enterprise at large, and how this partnership between public and private to be able to address this in both a defensive and offensive environment is paramount to making sure that we're successful on both fronts. Sound good? All right, fantastic. So let's get this thing started. Fernando Mamie, please, if you would.
Hi, so my name is Fernando Aimee, and I am a lead scientist at a research company in Michigan called SOAR Technologies. We do a lot of research in artificial intelligence primarily for the Department of Defense. Really, so I was told not to say this, so clearly I'm going to say it. I feel clearly outgunned by my distinguished colleagues here. I'm going to pull a Kobayashi Maru on everybody, and I am going to ask that we change the rules of the game a little bit. And let's de-emphasize or even wipe out the letter I from ICS and just think control systems. Because really it's a superset of what we're going to talk about here today. And if you play along with me for a little bit, you'll see that we have these very robust efforts underway to secure our critical infrastructure, ICS, SCADA, to arguably different degrees of effectiveness. But if you think of this as a control system problem, a control system by definition does three things. It senses, it thinks, or decides, or obviously computes, and then it acts. So it senses an environment, it thinks about it, and then it does something to change that environment, which gets awfully close to what my bread and butter is in artificial intelligence and autonomous agents, right? So now, if you take that broader perspective, then a lot of things fall into come into the conversation that would otherwise be left out, like your Nest thermostat at home, and how that could or could not be leveraged to bring down the entire grid. And how individual patterns of behavior, if we want to eliminate a key player in a particular enterprise, the one person that is able to bring back, whatever critical system it is that we're targeting, if I ensure that person's car breaks down halfway to Tulsa, Oklahoma, in a place with no cell phone coverage, then I effectively take out the ability of an organization to respond to a threat. So it is this kind of a micro-targeting and very, very broad view of the problem set that I get excited about. So I'm gonna break it down to three bins real quickly in my 2 minutes. Now,
yes.
Now 1 minute. And the first one
I'll give you
is
an extra minute. That's a bonus minute.
Oh, thank you.
You're very welcome.
So the first one is, let's look at the future. So let's think 10 years out, and there's this wonderful effort being undertaken or carried by the Army Cyber Institute in conjunction with the threat casting lab at Arizona State University, which is imagining a future 10 years out. And when you look at problems 10 years out, you start seeing some patterns emerge. One of which is this idea of blended attacks, right? So I don't necessarily want to take down the power grid or choose whatever sector of the critical infrastructure by a direct attack, just like we do in the we no longer do. Just like I used to do in the military, we prefer an oblique attack or a flanking attack or a rear attack because it's a lot easier to take down your target that way. So if you're thinking of it in that respect, then that whole thing about the Nest thermostat starts becoming a little bit more interesting. And harvesting information from social media on my potential targets, micro-targeting becomes a little more interesting. And if you can do this all at machine speed, then you win because the defender will not be able to respond in time. So you have to think of future threats. Then you have to look at the connectiveness of it, which is my second bin. Everything is interconnected, which creates, so we have complex systems that are interconnected into even more complex systems. And what you end up getting is emergent behaviors that not everybody fully understands because they're intractable. We can't possibly understand every single aspect of the behavior of a system in that aggregated way. And then the third bin the one that I feel most passionate about is then how can we take what we know about the future, what we know about the connectivity of everything today, and then how do we defend cybersecurity systems that are able to respond at machine speed to prevent these sorts of attacks. And that's where autonomous agents come in, and that brings you full circle back to that sense, think, and act paradigm of a control system, which is identical to what you have in an autonomous intelligence system.
I like it. So I'm going to ask you a question first because everyone has the opportunity to ask questions after each one of the speakers provides their opening remarks. So hopefully you're all actively thinking right now what you're about to ask Fernando, and the harder questions are preferred. But I'm going to ask you a question to piggyback off that right away because I think you brought up something that's very interesting. So there's this common perception that, okay, well, we need to protect the grid because people are going to attack the grid, right? Well, you just gave an example of you never physically touched the grid in any way, shape, or form. What you did is you touched something that's connected to the grid that can potentially send a demand signal to the grid. And that's problematic in a number of ways. One of which is that's not something that the IT capabilities within the electricity industry are going to spot. What is interesting in that circumstance is that it's probably not commonly understood that it doesn't take major fluctuations that fall outside of the standard deviations of load demand on the grid to cause really, really big systematic problems. So the '03 blackout, right, was not some massive storm. It was not the result of some terrible event. It was ultimately a grid operator failure because of bad data that was being seen in the system that influenced that command decision that was being made as to how much electricity was going to be delivered. And the next thing you know, 40 million people don't have power. So in that particular instance, what comes up as interesting in my mind is that you may not have the IT professionals that see it first, but if we see an anomalous activity on OT systems based on demand signals that don't look like the normal demand signals that we see, where do you see the opportunity to crosstalk there? So an autonomous system, very difficult to be able to spot those types of things on the back end of it, meaning on the operational side. It may see it on the IT side, but communication has to happen between those two.
Right. So the obvious place to start picking down low-hanging fruit, I think, is bringing the right people into the conversation. I mean, just think, I'm not going to ask for a show of hands because I know, I'm pretty sure what the outcome is going to be, but think of the last time you had an exercise, a security exercise of any sort, in which at the table were representatives of all the stakeholders, not just the security people, not just the OT people, not just the IT people, but everybody who has a role to play in a potential response, right? So just having crosstalk is already a huge step in the right direction, because now you have the things that I'm concerned about are way different than the things that you're concerned about, and we're all kind of in the same bin now, projected to a whole bunch of other industries, and that just amplifies the space of the problems you can start looking at. In that complexity is, I think, where you can leverage a lot of intelligence systems, because we can only tease out a handful of these things. If we sit down and bring the best heads together, which is the necessary first step. I mean, you cannot overstress the importance of bringing people, humans, to talk to each other and share ideas. But then if you augment them with intelligent systems, then that takes it to a whole different level, because now you can prioritize some of the more concerning threads or issues, and you can throw an autonomous system that can look at a few million different possibilities, branches and sequels, and explore a very, very complex graph very, very quickly and say, oh, yes, Jonathan, you picked this one up, but look at what happens if I pull on this thread.
Right.
And then the entire world collapses. So whether it's
That's
likely...
a good thread to keep an eye on.
Oh, yeah,
Typically speaking, if you can find the one that makes the world collapse, you should keep a close eye on that.
Yeah. So I'm a big fan of getting people from diverse backgrounds talking together. If my interests and your interests line up, then we shouldn't be having a security conversation. I should be having that conversation with somebody whose interests are different than mine within the organization, within the society.
Yeah, I think it brings up an interesting point, because I know for us it's not something that in a joint industry and military training environment is not something that we see with great frequency right now. We may see it in onesies and twosies. There may be some kind of high-level, policy-level conversations that are happening, but we definitely haven't done a deep dive into that particular area. And this is very real for us. During the solar eclipse that just happened, we had an inexplicable decrease in demand on our system, which is the exact opposite of what we were anticipating. We thought when all that rooftop solar went away for a few hours that we would see an increase in requirements. Instead, we saw a drop of about 5,500 megawatts on our system. Totally unexpected. Turns out we found the largest single contributing factor to it was Nest had a Save Energy Day. We didn't know this was happening, so they had this whole promotion that you would set your Nest during the eclipse to go to a cooler temperature because you didn't need it because it wasn't going to be as hot out, presumably, and there was a 3 to 5 degree drop in temperature, but they didn't tell us that. So suddenly we saw a drop in demand on the system that we were not expecting, and that's a big operational problem for us, but no one told us that was a problem. Now imagine if that was an unplanned event. We're just talking about, hey, you guys are controlling demand on our system. You should give us some kind of warning if you're going to do that. Imagine if it was unplanned. Who's the first one that's going to see it? Well, in the majority of cyber incidents that were reported to DHS, it's somebody outside of the company that's affected that sees it first. It could be that somebody within the DoD enterprise sees that type of exploitation underway. Who do they communicate that to? Would they normally think, well, if there's a vulnerability in Nest, I'm going to call power providers? Probably not. That's probably not going to be their first call, and yet we would be the most adversely impacted by the exploitation of that vulnerability. So any questions pop up as a result of that little dialogue yet? Or do you want me to just keep pounding away at Fernando until he just gives up? Yeah. Back right, all the way back right. My right, your left. Sorry, everybody.
It's a hard question. You take it.
Yeah.
So,
Sorry, my
full
mic's
disclosure, it's not necessarily specific to that conversation, but
Sure.
I do have an interest from an academic perspective. If you were to look ahead 3-5 years, what sorts of solutions would you say need to be in place for control systems, industrial control systems, that academia should be focused on now in order to be a bit more proactive in the solutions versus reactive? What do you project in your 3-5 year window?
That sounds like fun.
Sounds like fun, and I'm going to give some thoughts, and I think I'm going to punt also because I know that these two characters are going to have some interesting insights into it. But I'm going to come back to the need there's two elements in the conversation. The first one is if we're preparing students in a very, very linear and a very, very narrow focus, then we're already at a disadvantage. So I'm a firm believer in liberal arts education. You give them a very, very broad background, and you bring different people into the conversation. So I harped on that already. And also from the more specific perspective of what kinds of technologies do we need to be developing, and what kinds of science do we need to be putting inside of our students' heads to prepare them for that world. I would argue that two things. The first one is that the things that are deployed today are probably going to be of less importance to your particular target group than the things that are now causing the folks in the establishment to get uncomfortable. So if whatever paper just came out in a conference recently is making Joel very uncomfortable from an operational perspective, then that's an interesting thing to be pursuing for your students, because that's likely the technologies they're going to face by the time they're at the peak of their career, 10 years down the road, 20 years down the road, are going to be the things that are being invented today.
So maximum discomfort is what you're looking for as you're writing papers.
Yes.
Make people as uncomfortable as possible. Tim, do you have any touch points with research and development, or is that not your thing?
No, not at all.
Yeah, that's okay. Just wanted to make sure.
So I am in academia. I'm part of some of the largest centers that are looking at these types of problems. So I guess rather than go into the rest of the hour and 15 minutes of talking about research gaps, I'll just do some pointers. So look at the Cyber Resilient Energy Delivery Consortium. CRED-C.org. Look at the Critical Infrastructure Resiliency Institute. That Critical Infrastructure Resiliency Institute is a DHS Center of Excellence for Cybersecurity, looking at DHS's critical infrastructure segments and correspondingly the control systems associated with those. CRED-C is looking at specifically energy delivery, so electric power grid, oil and gas. Predecessor to that was TCIPG, Trustworthy Cyber Infrastructure for the Power Grid. These are all centers that the University of Illinois runs, but there are lots of other efforts out there. But the reason to point to those is look at the research threads that are being looked at there, and those are often correlated fairly well with what industry views as the gaps, because those programs work with industry and they're driven by industry, but they're also funded by the government, so they focus on the things that the government is concerned about, which in theory should be a little bit broader and longer term than what industry is necessarily considering. And so that's a good starting point to look at those areas. But to flip that on the head, don't look at just what people are working on now. Look at the goals that have been identified in things like the roadmap for secure energy delivery. Look at the funding calls that are coming out from DOE, DHS, DARPA, et cetera, and some of the problems that they're trying to tackle and the gaps that they see. Another one, for instance, DARPA is the RADIX program, Rapid Attack Detection, Isolation, and Characterization Systems. There are lots of others that are focusing on control systems in a broad sense. And remember that it's not just the electric power grid. Control systems are everywhere. So look at building automation and the work that Mike Shipley is doing in that space on behalf of DoD. Look at all those areas and you'll find plenty of problems. The key there is the interconnectedness. So you're not looking for problems in a particular silo. You're looking at those problems as they cascade, because that's where the real problem is.
Sure. And most importantly, obviously, energy is the coolest and best.
Sure.
If you're going to look for anything, just generally speaking. Boo. Oh, boo, boo. All right. So, Joel, what I want to do is pivot, because I know that you have both an answer to that question, but also want to give you an opportunity to provide kind of your what keeps you up at night. Now, obviously, I know General Mattis keeps everyone else up at night, but what keeps you up at night, Joel?
Okay, so my name's Joel Angel. I'm the Director of Industrial Security Services for AECOM. And there's a very specific reason why we worded it security services and not cybersecurity services, because we believe that there is a strong convergence. And it was really nice yesterday to see General Nakasone talk, and 2 other speakers mention the magic word of spectrum. So we believe that this whole problem revolves around not only the traditional cyber and physical domains, but also blending it with the electromagnetic spectrum. So what's keeping me up, and it's been keeping me up for many years, from about 1982 to roughly 2007, I was involved in designing automation solutions for infrastructure around the world. I mean, so I built new oil refineries in Vietnam, I put in pipelines in Chad, helped develop the Orinoco Valley in Venezuela. So I actually have a really good feel for what's out there in both developed nations, developing nations, and what we did like in Chad, third world, how infrastructure is being procured, designed, and installed and maintained. And we have a real problem. And there's a lot of spurs we could take off this problem. The first one is there is a massive confusion about what a control system is. So whenever I see the word SCADA thrown against ICS, it's like the concept of a supervisory control and data acquisition system is one very small piece of control systems. But control systems, we all know them. You have control systems. You have control systems that are weapon systems. You have onboard ship management and control systems. We generate power with them. We boil oil and make refined products in oil refineries. But the inherent problem that we see, and it was so nice, Army Corps of Institutes had their annual meeting a few months back here, and I sat with Greg Garcia in one of these exact panels, and I was very impressed. He got up there and he said, ICS is not IT. And when will people stop trying to treat it that? And of course, I wanted to stand up and clap and jump up and down, because that, I believe, is probably the biggest hindrance in how we're trying to fight this new war. They are trying to fight a cyber war against control systems using information security TTPs, and they're not working. Because one thing, being an implementer, that we can do is we no longer depend on system vulnerabilities or software vulnerabilities. We know how to exploit capabilities, the ability to use the system to our advantage. Because as soon as you start thinking along those lines, and forget this idea that you're going to drop malware or you're going to dump payloads. No, we're going to use command sequences that are valid, authenticated command sequences against control components that are going to cause them to do the wrong things. So I love stories, and I'm glad that this one never did happen, but let's take a little flashback 17 years to that day in September. Some people decided to take over an airplane and manually fly it into 2 buildings. Terrible event happened. Now imagine if you were able to actually get access to the control system and issue commands that would have sealed in those 2 buildings. That is not that far-fetched. At that time, cyber was very green, and nobody ever would have expected a threat actor to have those kind of capabilities. But it's been 16 years, and the sophistication of the actors has significantly improved. So we see this tendency to try to fight this new cyber war with far outdated tools that don't work. And we also fail to truly identify who our threat is and what they're trying to do. So in my job at AECOM, I have the benefit of being able to work both in public and private projects. It's only the defense type documentation that understands this concept. It's not the system that's important, but it's what the system's doing. It's the mission essential functions that systems, or system of systems in most cases, are trying to do. So the idea is this misunderstanding that we're going to follow some information security standard or guideline against an operational problem that represents operational risk because it's risk to our mission essential functions. And that is probably one of the greatest challenges I face with every single client, is that they don't understand, stop looking at the Windows XP box that you have and everybody knows is outdated. Let's focus on what that computer's doing and how can we guarantee the assurance that those functions will never be hindered. Because it's not the attack of the asset that's going to cause the consequences. It's going to be the attack on the functions that those assets provide. So when we talk about what keeps me up at night, there's so many things, but that's probably it.
So you're saying here in front of everyone that Windows XP is outdated for sure?
Maybe.
Okay, all right.
But
Well, you heard it
I
here first,
guarantee you,
folks.
if we did a poll in here, 50% of the people probably still have XP running on operational systems.
Well, I can tell you that's one of the challenges we see in the utility industry, right? Is that it's all scales, all types, right? There's over 6,000 utility just on the electricity side, and some of them are mom and pop shops, right? The same guy who runs the OT systems for the grid also picks up trash on Wednesdays and handles the recycling and those types of things. It's problematic. Life cycle replacements of hardware, software, all that stuff is very problematic for sure.
Right, and the thing that we always, and you guys and the people that follow RMF understand this whole process, is that unfortunately a system that works can be secured if you know how. So the answer is, don't say replace your XP box because it's outdated. Secure the functions, and that's really where we start to see these big problems. Shoot, XP, I love seeing XP machines. We run in and see Windows NT and prior to that machine.
Nice.
Yeah, oh yeah.
Good stuff.
So the idea now is to not blame the product, but solve the problem. And that's really the greatest challenge, and that's why when we try to have workforce development events, then there was one yesterday. This whole idea is that unfortunately, to train the workforce, this is not an IT problem. This is a fundamental problem of the system. So it's a systems engineering problem. And when we really start talking about securing systems at that level, some of it can be done at an information security or application layer. But in general, it's the physical environment that we have to maintain integrity and operation of. It needs to be safe, it needs to be efficient, it needs to not harm the environment, it needs to not harm people, and so on.
So I have two threads I want to pull on out of that first, but I just want to make sure that the audience knows they still have every opportunity. I'm still glancing out of the corner of my eye for questions as they come up. Okay, we've got one right up here.
Hold on, please.
G2, is that what you said?
He said 867-5309, I think is what. Okay, I got it.
Hey, Chris Wade, Damo Cyber, G357. So as we look at how people are taking these systems, and we talked about, basically the smart installation, and we want to take the IT systems and combine them with our OT systems, therefore introducing vulnerabilities ourselves to the systems. So we want to control them, we want to be able to tell them what to do, but then you're talking about, how do we properly structure and build these systems? Where do you think that line needs to be between how we integrate IT and our OT systems into these smart installations or smart house, the Nest back into my or your temperature control? How are we doing all of that, and what do you think is the best practices? Do we just draw the line and keep with our manual OT systems, which prevents that? But it sounds like it's all mainly just an access problem from getting from the IT to the OT side.
Correct. So there's a lot in there. So the whole integration era was kind of interesting, and it was fun to live through it, because in automation and control, we kind of went through three kind of plateaus to where we're at today. Of course, the first one was the introduction of automation and distributed automation in the 70s and the early 80s. But in the 90s, when we finally made this move to go from a proprietary platform where people would spend upwards of $50,000 on a single CRT, 640 by 480 pixel resolution HMI, human machine interface.
Wow.
Yeah,
Fancy.
shocking.
Fancy.
$50,000. And normally there would be a dozen of those in a plant. So, right, you just spent $600,000 on some CRTs. So we made that transition in the 90s. We all made this detour into the Unix world that failed miserably. So we kind of laughed, right? We thought that that was the way to go, and everybody today says, what are you using Windows for? Why don't you use Linux? And it's like, we tried and failed. It didn't work. So anyway, so we picked Windows, and then we had this integration. Everybody said, wow, let's interconnect the world. So what happened in the mid-90s is everybody interconnected everything without giving any thought of, do we really need to do that? But of course, if you think about 1995, there was no term cybersecurity, right? Very few people were doing real security. You might have a perimeter firewall in your enterprise, but the extent of, shoot, we were just beginning to widely deploy email systems in that time. So as we moved forward, the one thing that we saw is we started to try to remove the burden of the past. Because there was a GAO document written and published right after 9/11 that kind of talked about the challenges in securing infrastructure and the control systems that control them. And one of the 5 points was this tendency to want to do what you've done before. So you go in and you do an assessment on an architecture and you say, why is all this stuff interconnected? Do we really need it? So the idea on how we're making these systems work is we're starting from the ground up again and understanding the integration requirements and the data flows. And then I am a huge believer in segmentation or the creation of enclaves, as military DoD type terminology likes to use. ISA calls them security zones for the industrial control system space, but the concept is very valid. And the reason I like enclaves or zones is that I am a hardcore believer that you can't necessarily secure every asset. And an embedded device is a very perfect example. Tell me how you're going to install antivirus software on your Nest controller or on a PLC. You can't. But you can put all of those devices in a zone of their own and implement security on what's called the conduit into the zone or the connections in, where you can then do some of the new leading edge technologies that was asked by the woman in the back, is to now start doing the analysis on the incoming and outgoing traffic to understand if that traffic is anomalous or not. And then we're now able to take legacy products, put these in enclaves. We don't have to change IPs. We don't have to do any kind of network alteration, because most of the security appliances that work in the OT space, as a lot of people would say, tend to want to go in line without any impact on existing routings, right? So they're all transparent devices. So I believe that when we start to integrate these two worlds, they can coexist, they can share information, but in general, they tend to represent two very different security profiles. And since they represent two different security profiles, they should be treated as such when we start to provide this overall architecture.
You know, something I dogpile on is an example. So take Ukraine, which was kind of the watershed moment within the energy space or the utility space, to say maybe this is a bigger problem than we were leading ourselves to believe before this happened. So the Ukrainian fix to somebody hopping over IT systems and ultimately putting their hands on OT systems and throwing breakers was what? They went manual, right? Go manual. Rip every cord out of the wall and go manual. Sounds great. In the United States, do you really think that's possible on our electricity grid to go manual? I can tell you in our territory alone, there's 5,600 substations. Right. You're not going manual with 5,600 human RTUs providing real-time updates of power flows at substations. It's not going to happen. And our adversaries are familiar with this fact. So brace yourself for a statistic, okay? So 73% of all statistics are made up. However, above 90% of all of the transmission relays on the grid in Russia are still electromechanical on purpose. They're not digital relays, and there's a reason for that. They still have the ability to go manual on a lot of the systems, and they're trying to reduce their own attack surface area as it applies to critical infrastructure. So I think your point is right on track, which is saying that, you know, the manual option, what is kind of the frontier or the apex in terms of the level of integration of systems. Ultimately, I think you're at a point where you don't really have the ability to just turn around and say, we're not going to integrate IT and OT. There are too many inroads that are made right now in terms of the efficiency of operation that would ultimately hinder our systems where they stand right now. I like your approach of being able to take those enclaves, those kind of protected islands of subsystems, to be able to at least draw some lines in the sand so that if the breakers go, it's not every breaker. You just lose that one individual fuse, you can go back and switch. So
I want to do one quick story here.
Yeah.
Because field stories are always fun to kind of show how people tend to think of things.
Should I get a beer before you tell the story? Or
No, it's a 30-second one.
Okay.
So I'm working with a pharmaceutical company, and anybody that knows anything about that sector, they live and die by 21 CFR Part 11. That is a federal requirement around basically the documentation and association of maintaining the integrity of their products. So I sat as an advisor to them, and we did every threat scenario in the book, and there was no way you could actually hack a system and taint a drug. It can't happen because 21 CFR Part 11 has so many out-of-band problems. So now you run into this wall. How are we ever going to fund cybersecurity if we can't convince anybody that it's going to impact the operation from a safety and security point of view. So I said, well, change your approach. Can I see your efficiency ratings for some of your factories? So I decided that we would start in China. Their factory efficiencies were below 70%. That is appalling by most manufacturers' standpoint. The main reason is they couldn't keep the plants up because they were so infected with so much junk, right? The operators at night would plug their phones into the HMIs and stream videos on their HMI consoles. So they would create internet connections to, these were regulated networks that you're not supposed to be able to do that on, and cause problems. So we had to start all over with this company. They effectively, we had to retrain their entire workforce and buy a couple computers that are connected to the internet so they can stream video. But what was really funny in the story was the primary system that pharma companies have is called a manufacturing execution system. And that particular product's based on as a Unix-based system. So when we started to talk about securing the infrastructure, they said, we don't have to worry about that. There's no viruses for Unix. And I said, come on, you can't think that way. So what we did was we did a little test, a little quick 20-minute penetration test. I got on their computer. Of course, it was running outdated Oracle with an outdated Oracle SQL connection API. So we immediately compromised Oracle on that computer, and since that computer is not used by that many accounts, it immediately gave us root access. Then I said, this is connected to your SAP system, isn't it? I go, watch this. And we immediately hit the SAP system, but stopped there. And I said, here's how you do it. This is actually an exploit that's available for sale that will show you how you can compromise SAP. You talk about a company changing their perspective on cybersecurity overnight. And it was really a good approach into how we, again, created this idea of integration of very separate zones, because that network, I never believe it. People say nobody's really got a flat network. This industry, those plants, had one big flat network. They had office computers, printers, and control system equipment on one network. Of course, there's different switches and stuff associated with it, but hierarchically, from a network point of view, it was flat. And by today's standards, that's absolutely not acceptable from a security point of view.
Well, if you want an open concept house, you want an open concept network. You're getting it all wrong here. It's all about, it looks much nicer. Well, the good news is, I know DoD does not have to concern themselves with similar problems, because soldiers, sailors, airmen, and Marines would never take a personal device and plug it in to a government computer. So obviously that's not relevant to DoD, so that's helpful.
Or use USB sticks, or
correct, yeah, no,
put documents in your
does not happen, does not happen. So the good news is that problem solved.
Actually, if I can pile into something Joel just said, because you mentioned the concept of enclaves, but then you mentioned something that I want to come back to, because I see it in my world as well, and it's that analyzing the flows in and out of the enclaves. You know, what is going through those links? Because something we see in the work that we do for embedded system security and platforms for the military is that, okay, so that's, you know, it's an F-35. It's completely isolated. There's no way to get on it, right? Well, yeah, there is. There are multiple. Even if you buy on the whole concept of air gapped, there's all kinds of ways to jump the air gap, right? So the idea is to change. I think to change our mindset and say, how is that system communicating with other systems, not whether it is in the first place or not, because it will communicate at some point in some way, and that's something that I think bears underscoring a little bit.
Absolutely. So we've been saving somebody for you, everybody. We've been saving somebody, just ready to totally stir the pot. So that's why I'm excited to have Tim. So Tim, why don't you go ahead and take an opportunity here?
Look more excited.
Ooh, stir the pot.
Yeah.
So I'm Tim Yardley. I'm at the University of Illinois. I have been doing research in industrial control systems for about 10 years, primarily focused in the electric power grid, but also dealing with other sectors. I'm involved in all those centers I mentioned before. I do work in space technology and some other things as well. Let's say my prior life, the techniques that we defend against today, I'm one of the people responsible for creating those. So the take that I'll talk about here is I'll start this with a question, which, how many people in the room are interested in cyber conflict from a defense perspective? They want to defend the systems that are potentially being attacked. Okay. How many people want to attack the systems in this group? So several of you had your hand up for both. So I brought this up in a panel before as a question from the audience, but let's sort of dive into that a bit. So first off, skill-wise, how many of you have touched industrial control systems? Okay. How many of those were touching the components versus looking at the system operation? Okay. How many of you can do a full system analysis of an industrial control system looking at it from an operational perspective? Right. So this talks to what Joel was talking about, which is industrial control systems are using old technology. It's not uncommon to see Windows NT systems, Windows XP systems, et cetera, that are running these. Do you need the latest and greatest exploitation techniques to get footholds on those systems? No, you don't, right? And so the software that's running on these is, in a lot of cases, equally old. You're starting to see that change. You're seeing modern systems being developed with modern protections or getting bolted onto these systems, but they're bolt-ons, right? So if you, let's use a Swiss cheese metaphor here, we can have a solid block of cheese, or Swiss cheese in this particular case has holes in it, but if you slice it enough times, you'll find some slices that don't have holes. That's fine, but keep slicing and you'll get holes. And so as you start looking at the protection mechanisms that are there, eventually you will find a vector. The vector could be to bridge the air gap. It could be to exploit a human to plug something in, or to make them, want to stream a video off YouTube, or whatever it may be, right? There's a lot of other ways. You can use radio waves. You can use sound. You can use all sorts of things to potentially cause problems and cause actions. So it's not about how do you break the system or get a foothold on the system. It's what do you do once you have that? And from a defensive perspective, we need to remember that. The intruders are going to get on the system. So how do we detect that they're there? So DHS, they released in their ICS report that I think the average time to detection for a compromise, 252 days? Is that what it is? 252 days. And so, again, statistics are made up, so who knows if those are real or not.
73%.
But that's a long time, right? Somebody who knows how to actually deal with the operations of the system. So if you ask Joel or ask myself, what could you do on the system in 252 days to cause problems? We would just start laughing, because we wouldn't need 252 days. We would need probably 10 minutes to figure out what to do on the system. Now, let's use Ukraine, which was brought up earlier. Ukraine is interesting from a wake-up point of saying, look, somebody has the audacity or the gall to actually take out a physical grid in some way, shape, or form. But if you look at what they did, it wasn't really all that complex. You could put Joel and myself in a room, and we could come up with probably 50 different ways to do more interesting things. And of those, current technology would be able to detect maybe one of them if you're lucky. And so there's a gap, right? There's a problem there. We don't have to be sophisticated. It's just we understand how the systems operate. I'm not a power engineer. I'm not even an electrical engineer. I'm a computer scientist. And I was able to learn how the systems operate and learn how to exploit them. But I also am a former hacker, so I think differently. And remember, the people that are attacking these systems think differently too. So you arm them with information of how these systems operate, and they'll figure out how to abuse that, because that's what hackers do. So we can educate people all day long. We can teach them how systems operate. We can teach them how to hack. We can teach them how to run things like Metasploit and how to run scanners and stuff like that. But that's not the hard problem. The hard problem is, well, they can do it, but what do they do with it when they're there? And that actually doesn't require exploitation. You just use the software that's there to do what you want to do. You just have to know the vector by which you want to do it and what you're trying to accomplish. So on the defense side, I just said that the tools that we have are modern and current and doing great things, but they still can only detect maybe a handful at most of the nefarious things we do. So let's talk naively about what some of the things we've seen in the public are. So we've seen a implant, or whatever you want to refer to it as, an exploit where it's sending breaker open commands on a regular basis. Just doesn't care where, it's just firing them off. Very, very naive. Effective, it opens up lines and it causes outages in theory, but naive, right? And noisy. Can intrusion detection systems that understand industrial control systems detect that today? Yes. Can IT systems detect that today? No. Can things like Snort inherently detect things like that today? Not really, unless it's told to look for something like that. So even that naive one of just be a monkey and hit all the buttons can have impact and little visibility. The only way that you see it is, oh crap, the power lines are the power is going out, these substations are going dark, these areas of the country are going dark. So what if we were more crafty, changing things like set points, changing things like behaviors, changing things like ladder logic? Oh wait, we've done that, right? Or somebody did that. And so you can cause more nuanced things. And those nuanced things can be impactful in some way, shape, or form. So if we're on the defense side, how do we detect those nuanced things? Well, first we have to know how the systems operate. Who in this room knows how those systems operate? The people that operate them. So combine the knowledge of the operators who don't understand military doctrine, they don't understand attack methodologies, they don't understand attacker TTPs, but they understand their systems. And the military entities, or the let's say, people with the offensive mindset who know the offensive techniques, but they don't know what to do once they're on the systems necessarily. They can figure things out like a monkey, or they may figure things out specifically in some cases. But combine those two knowledge bases and you have an interesting combination, both from an offensive capability and from a defensive capability. But how do we transfer that knowledge? Because there are things that, for instance, industry is not read into. One thing is you're expecting them to defend against nation-state adversaries in some way, shape, or form. They don't have the intelligence information to know what those nation-state adversaries are doing. And in many cases, they aren't able to even be read into those things. And then you have the people in this room and other places that are read into that information, but they don't have the context of knowing what it means and what those people are doing and how that could be potentially bad, especially as you get into the connectedness of the world. It's like an actor may be doing something that seems to you rather benign to the power system, like playing with Nest, for instance. You wouldn't even think about it in terms of the grid. But Jonathan over there was concerned just because Nest said, hey, customers, save some money today, right? Imagine if an adversary is doing something worse. And so that's fine. But those connections are the things that you, by having the domain system information, you would be able to see that are apparent in complex campaigns that you wouldn't otherwise see. And so I'll stop at that point, I think.
Yeah, I think it's good. It's certainly something that I would say keeps me up at night when I think about it from our perspective, being the private sector infrastructure utility perspective, is that cyber incident management, as an example, is very complicated for us. From the volume perspective, so my company gets attacked about 3,000 to 3,500 times a month, which is anything beyond reconnaissance phase in terms of the kill chain. But in terms of what we see from a volume game, we don't know, or we don't think that advanced persistent threats are the primary thing that we're seeing in our system. Usually it's just kind of the opportunistic cyber criminals, people playing the volume game, looking for easy scores and that kind of stuff. If we were actively involved in a back and forth cat and mouse type of cyber hunting mission against an advanced persistent threat, we don't have the training or capability to do that. And that's not about highlighting vulnerabilities organization specific. I could not possibly name a single utility in the United States that says that they have that type of in-house capability.
There's an interesting point on that too, which is the adversary knows that.
Right.
And since you don't know the adversary and they know you, that cat and mouse game is maybe what they exactly want you to play.
Sure.
And wait for you to make the wrong move
Yep.
as they are distracting you to then expose yourself even worse.
Right. If we apply our own processes that are typically geared towards the typical patch management, vulnerability assessment, that kind of stuff, it could be that's exactly what they want us to do because they can watch those procedures and then we're only adding to the vulnerability of the system. On the flip side of the coin, what's interesting is, I think that you raised is, when you look at those operations systems, those grid operators, masking your activities from the IT folks, that's a well-practiced art now. That's a more developed capability. The really interesting thing is, on the offensive side, if you were to go into an infrastructure system or an ICS or a SCADA system, what have we done to develop a capability? We holistically, now I'll put my green suitor hat on right now and say, what have we done to develop a capability to mask our activities from the grid operators? In all likelihood, in those types of circumstances, they're the ones that are going to see it first. It won't be the IT people, but every time a breaker opens, we don't call the IT department, right? Every time a breaker or a relay opens on our system, we don't say, my first thought is I should definitely call IT. So what type of pattern recognition or anomaly detection are we doing that bridges those two worlds?
I think that's an interesting point too, is that the attackers, a talented attacker is going to do all of the necessary information gathering in advance to know exactly what your procedures are step by step when something happens. So if they're opening breakers, they know what your operators are going to do about that.
Yeah.
And they're going to use that to their advantage, because your operators aren't even going to begin to think it's a cyber problem until about step 20 in their why are these breakers randomly opening?
And to make matters worse, we have IT applications that govern some of the decision models for the grid operators as well, of being able to say, well, if this, then this. Now, it doesn't go to full autonomy and say, I'm going to close that thing for you or take care of it, but just the alerting mechanisms and applications we have around that type of stuff are potentially vulnerable themselves. So it looks like you have something to say, Jim.
Yeah, man, so many.
Just one thing, and then we have a question too.
Great. So the interesting thing that when we try to get people to understand the whole idea behind automation and control is that unlike a typical information style attack, the actor's actually going to do the action that he intends. So he's going to exfiltrate data, or he's going to drop payloads, cause destruction, something like Shamoon. But the one twist that we've got when we talk about automation and control is the ability to cause the operator to think one way, understanding and knowing that he's going to use the system to react in another. So probably the most basic analogy I could think of without getting too much in the trenches is post-September 2001, we had a fear of anthrax coming in and contaminating our water systems. So a very simple approach to what I was saying is it's easier to go into the system and make you think there's anthrax in it than there is to put anthrax in the system in the first place. So another good example, and again, these silly Die Hard movies, because from a hacking point of view, every movie.
So good.
Yeah, I love the one that was really the hacking one. But if you look at, I think it was number 2, the going in and altering the sea level on the ILS system, right? That caused the pilots to actually think they were at a certain level and react accordingly. That's the one value that we have in control systems that, again, makes a traditional detection mechanism very, very hard. Because the idea is an attacker that understands, of course, if he's attacking a process, he has a motivation and a reason why. So if it's to cause an oil refinery to explode or whatever he wants to do, I'm sure that the person has done enough research to understand the automation and control concepts. And that's where this becomes a very, very big challenge, was because now, again, what I had mentioned earlier is we are not exploiting we're not exploiting softener bugs, something that could be fixed with a software update. We're actually exploiting a capability of the system. If I say the pressure is high and you know it should be low, you're going to do something to react and make that pressure go low. And to give you a catastrophic consequence that was not cyber in any way, but by today's automation standards is a very easy attack, was the British Petroleum Refinery in Texas City, Texas, about 10 years ago. They had a faulty level indication that caused all the operators' actions to try to deal with the level being at that particular height when the level was significantly higher. So of course what happened is the level went out of a vessel, it went into a gas line that it shouldn't have been, caused a significant sequence of events downstream, and eventually the plant blew up. 20 people were killed. It was a significant event. And it had actually an enormous impact on our economy, because that one particular refinery made roughly 4% of the motor gas for the United States. So again, kind of like taking things off the power grid by just moving Nest down 5 degrees, same thing here. You take 4% of the supply chain for fuel off the market instantly, we have a disruption that could be a window for an attacker to actually use other types of attack vectors.
Well, we know it's not a real threat unless there's either a Die Hard for it or Tom Clancy wrote a book about it. So we're definitely on track, though. It sounds like we have a question back there.
So because I've been holding the microphone for 2 days now, I'm going to claim executive privilege for once. And so
Do it.
my question is for all of you gentlemen. So First of all, I'd like to thank you for your points, in particular, Tim, yours. They were very on point. But they caused me to think of Rob Joyce at 2016 USNICS when he was still the chief of TAO. And his comment in his speech was, TAO is successful because they know your equipment and your configurations better than you do, to include even how you think you do. How are you as operators combating that so that your operators know their equipment and their configurations exactly what it should and should not do?
I'll take a stab at that. So I'm not an operator, but I'll tell you that in my experience in dealing with the operators, they don't know their systems at that level. They know what their systems are functioning as. They know how they're supposed to be configured, and they can recognize when things aren't functioning correctly or aren't configured correctly, but they don't know it at the intimate level of detail. So if you ask an operator, what protocol is being used from device A to device B? What functions are being called under that protocol? What are the targets of those functions? What's your response ratio that you see on these? Do you see retransmissions? You know, other things like that. If you ask them questions like that, they won't know. If you ask them, they can figure it out, they can find it out, but they won't know. Some of them don't even have the visibility to tap it to then tell you an answer later, to do a capture to say, oh, this is what it is and this is how much it's talking. Let's put it on a different perspective. When you click that button that says reset the device or reset the breaker or whatever, what does it actually do? Most of them won't know. How do you determine if it did what it was supposed to do? Well, the line closed or whatever, and now I see power flowing. What if it doesn't? Is the breaker open or breaker closed? Well, the breaker's obviously open, right? No, not obviously. It could be somebody that's fooling you, right? So I would say that they don't necessarily have that knowledge. So it's not surprising that the attacker would, because the attacker wants that level of knowledge to exploit those fringes, exploit those edges. And so how do we get better? How do we put systems in place that can tell us how our systems operate, to develop those baselines, to tell us what is normal? There's all sorts of approaches, statistical, machine learning, blah, 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 blah. But the problem is a lot of them inherently don't understand context. So even once you have a baseline, let's say the aperiodic nature of control systems are that breaker open commands, select before operate breaker open, does not happen on a regular basis. So you develop a baseline and you may never see that in your baseline development unless you run over an extended period of time. But it may be a perfectly normal command. And so how do you deal with that in the feedback loop of, yes, that's normal, don't stop that? And also the notion that if you have a protection system, something that's going to stop based on anomalies, you may be stopping a mission critical operation that could cause a whole bunch of problems. So you allow it through and you hope it's right, but how do you verify that it was right? And you have to look in both the cyber and physical silos to determine that.
Yeah, the joint training environment, and I think this speaks to your earlier point, Joel, about security systems, not IT security, not physical security, the integration of security. That's something that we grapple with on a regular basis, is the IT elements associated with what those grid operators are seeing. Our grid operators spend a quarter of their entire career in training. Out of every 8 weeks, 2 out of every 8 weeks is just spent on training and retraining. And the question is, how are we leveraging that type of time? Imagine the data sets that we could capture in that training environment to be able to establish some of those baselines for anomaly detection that bridge that IT/OT gap in a lot of different ways. So it's a good question.
So I was kind of expecting to disagree more with Tim today. And what, you want to do? Take it?
No, take it.
Okay.
You're good.
So yeah, so I was figuring we'd be having a fight up here, and I can't agree more with what Tim said. Actually, half of it was what I was going to say, and he said it, so I don't, right? No, but one thing I kind of want to let you...
I have to be more controversial.
I know. So what's interesting, though, is exactly what he says. I'm going to pick up on that. So, you know, there was a question about what tools and what techniques are we going to use to try to detect these type of events. So there is some exciting research taking place, and one of the ones that seems to kind of pop up with both some startups, but with some research. In particular, I spent some time in Singapore at the Singapore Institute of Research and Design, I believe that, and they're working in partnership with MIT. And they actually built a water plant, a water treatment and purification facility in their lab, and it's pretty impressive. It's about a floor of the building. And the idea that they're trying to do now is to actually look at the physical impact of automation modifications. So the idea is that it would be very difficult for an attacker to actually make enough simultaneous changes that it would appear as though the plant is supposed to be going in that direction. Typically what they would do if they wanted to cause an operational impact is they would target specific points and cause specific actions, like open a breaker. So in this particular case, they're doing a lot of research where they overlay the kind of a heuristics approach that if I do this action over here, I'm expected to see this reaction in these 2 or 3 other places. So that then when the action occurs and it's not followed by the reaction, they know they have an indicator of, I'll call it an indicator of potential compromise, not a true indicator of compromise. Because remember now, this is an operational system. So we would typically alert that there is an irregularity rather than react and all of a sudden start dropping traffic and start causing actions. Because you could, in fact, then do what the attacker wanted if you did that.
Sure.
So one of the things to add on to that real quick. So first off, they have more than a water facility now. They have a microgrid facility as well.
Yeah, the microgrid wasn't started up. Yep, that's right.
So I know that because I helped them design it. But the benefit of these things is that, let's say the naive breaker open. That's obvious. It has a physical immediate impact that you see, right? So I'll go back to something I said just a moment ago, which was about set point changes as something that's a little bit more non-obvious. So there's a load curve that happens. There's a load profile that one expects. Nest was an example of an unexpected occurrence in that load profile. So the load goes up during the day as people come into work and peaks at whatever point they make dinner or whatever it may be, and it drops back down when they go to sleep, right? So at that peak point of the load, for a naive load curve at least, for the peak point of that load curve, you're operating close to thresholds of the system. You're always operating close to thresholds on meeting the demand, but you're operating at a higher threshold. So you modify PQ values, you modify set points down here in the low point when they don't matter. And you happen to do those modifications in a concerted way so that once you get to the peak of that load curve, you cause an outage. But that was 8 hours after you made this change. No immediate impact. And now you combine that with something else that you happen to do at that same point. It's confusing because I do something at this peak point, it looks like a brownout, it looks like whatever it may be, and it's really not me taking actions to open breakers, it's your system taking actions to protect itself in the way that it's been told to protect itself. It just happens that I was the one that told it to protect it in the wrong way. And so now you have the system defending itself from failure, but defending itself in the wrong way. And the operator's taking actions based on what they thought the settings were and what the system should be doing, but now I'm taking the wrong actions because that's not what the system is set up to do, and I'm trying to hurt it by forcing it to do the things that right now it's not set up to do.
Not cool, Tim. Not cool at all.
And that's still simple. That's still simple.
Fernando, you're going to say something, and then we have a question. We have 2 questions, actually.
Right. So there's some key terms here that or concepts that I want to tease out a little bit. So Tim mentioned the context is important, and he also mentioned machine learning, and I think it speaks to a huge deficiency in current approaches to machine learning for intrusion detection or incident response in general, and that is that we're looking at point-in-time data. We're not looking at the context of a transaction. So if you change a value in a particular control system, is that good or bad? Well, it really depends on what came before it and what's happening after it, and not only in that particular process thread, but in related process threads. So you have to look across time to look at this. And then it speaks to something we're doing to address a point that Joel brought out in terms of tools and techniques. We have this notion of TTPs, and we throw the term around like it means something. It really doesn't, the way we use it in security context. It has a very, very definite meaning in military doctrine. But we don't have good cognitive process models of what is a technique, what is a tool, what is a tactic, what is a procedure, and why do we care? Because if we had such models, and I would argue we need 3 layers of models, and we're actually involved in some of this work already, and I would love anybody's ideas on this. We need 3 models. The first one is an adversarial model of what are the things that adversaries are doing, whether these are things that we have observed, that we can capture through sensors. And again, this has to be across time. It's a process model, not a point procedure model. And the second one is the defender model, right? So if I see an attack, what are the things, what are my defensive TTPs that I do in response to that? But a third one is, what is the normal behavior of an operator, of a regular user of your IT network, of a regular operator in your OT network, whatever that looks like, what is normal? And then once you have these three models overlaid on top of each other, then you can do some pretty interesting things with machine learning that will tell you across time, not only why you are where you are, but also where are you likely to be in the future. And that gets at real predictive analytics, which is something that it's kind of a holy grail. Nobody has done it right. There's a lot of hype on this right now, but it's all just trend analysis, and that really does absolutely nothing for the problems that we've mentioned before.
Well, one of the problems with
I'm going to transition to a question because I don't want to deny the access. So hold on to that thought.
Sorry.
Please. Yep, sorry.
Grab it.
How can I be controversial, man?
Love the panel, and I appreciate so much deep experience, particularly Joel. I mean, you've been working the grid since the TVA back in the 30s, so really glad you could make it.
Come on.
Took
just
part in
because I don't have
constructing
any
the Hoover
hair.
Dam SCADA system.
I feel so young
I put
now.
bubble gum down there.
So, this is obviously a prior question. I just wanted to know what your perspective was, given your point that you need to build out separate models. How are you taking that deep historical experience and marrying it with your operator who's doing navel gazing, making sure that his equipment is doing on and off, and giving them that overall mission perspective to think, what are the overarching things this system's trying to achieve, rather than I'm just getting the up-down signal out of it? How are you getting them drenched in the mission of the network, if you will?
Whew. See, that is a good question. I would actually say that we're not, right? So, and that was a good conversation flow that occurred on how do you actually help understand your system? Do operators really understand the system? I would add that I don't think most vendors that deliver and deploy those systems understand them. Maybe their developers do, but I've seen systems deployed where people had no understanding of what was actually going on the wire. So I do agree this is a far greater problem. So what happens is the core groups of these big automation and control companies create best practices. And the idea is that you design around the best practices so you don't have to understand that stuff. So I believe that that's one of the many kind of slivers, death by paper cut, is to things that we're going to need to do to improve. For instance, we go back to the Ukraine. The Ukraine showed so many very interesting aspects of an actual attack. They used some malware to get a foothold. Then immediately they did like every good attacker would. We searched for authentication mechanisms, credentials. And as soon as they got them, it was almost game over. But then all of a sudden, why an operator would actually watch somebody take control of his screen and not think that something's wrong, right? So yes, he's watching the mouse go over here and click breaker off. And things like that showed that, yes, they hadn't taken into account, and this is actually, I'll end it on this, probably one of the most important things, which is a cyber incident management plan, right? So the indicators of things that are going wrong, how you respond to maintain that, A, you don't make the wrong mistake, but B, you're able to understand, identify, and contain that as quickly as possible. Probably one of the most common policies that's missing in most plants is what to do in case of an attack. And for those few that actually have it, it's like, when's the last time did you actually exercise this? So there's so many pieces that I hope I answered the question.
Yeah, definitely. It's right on point. Yes, sir.
Thank you very much for your talk. Yeah.
He tricked you. He gave you a dead mic on purpose, I could tell.
He's going to take it and ask another question. That's why he did it.
Thank you. Thank
OT
you guys for
failure.
your time. So my name is Mark Caneas. I'm the cybersecurity staffer for Representative Derek Kilmer out of the great state of Washington in the House of Representatives. So let's say I got you a minute or 2 minutes with my boss to talk about cybersecurity. What's your biggest problem, biggest policy recommendation that we in Congress should be looking at?
Heyo.
Moderator, that's yours.
Yeah, seriously. So first off, kudos to Washington, I would say from a National Guard perspective.
National Guard, man.
Really
the best
well-developed
cyber readiness
capability.
team there is, yes.
Very well-developed capability,
Yes.
good integration with the private sector as well. That is a model of practice that needs to be replicated in many instances.
Concur.
And then what I would say is in terms of how we approach it specifically to this community, there have been a lot of grassroots efforts to try and build stronger and more detailed partnerships between say, the DoD enterprise and private sector more holistically, that's something that we need to really double down on in a variety of different ways. So whether you're talking about joint research and targeted investment, whether you're talking about some of these exercise and training opportunities, there's a wealth of knowledge, information, and capability on both sides that are beneficial to each other that are not being taken advantage of right now, that I think is a systemic problem that from a policy perspective needs to be codified in a more meaningful way in terms of creating the right opportunities to be able to do that. So that's a first foray into it.
So my take would be is you can't go a day without people talking about this workforce shortage we have.
Yeah.
So one thing I would like to see is that actually becomes more of something of a matter of policy within the legislature, and that something's actually done to address it. Because right now, we all are identifying a problem, but I'll tell you, I'm so glad, now forget the politics, I am so glad that President Trump declared critical infrastructure security as a focus. I was shocked that October, Cybersecurity Awareness Month, had 2 days for critical infrastructure. 2 days. I mean, obviously we're missing the point here. Is it really that important? So I would go back and I would say, if we want to solve this problem, we need to bring it to the spotlight of the Congress and start doing more positive action in order to help, again, regionalize, develop the whole STEM push. Why don't we call it C-STEM or something to introduce this concept of a broad, comprehensive learning of cyber as soon as they can touch a keyboard, right?
So I'm in academia, and I'll support the education aspect. I think that's important. But I think something that's even more important is establishing the trusted communication channels. I'm not talking about information sharing, but how many people in the room are from an asset owner operator entity? One. And we're talking about defending and attacking their systems. You want to have those conversations, have conversations with the people that operate them. They will enlighten you in all sorts of ways that you don't even imagine. And right now, they don't know you, they don't trust you, and so,
But I'm from the
work on
government
that.
and I'm here to help, right?
So that working on the pathways to establish those trusts, because let's just simply say, if or when we are attacked, when critical infrastructure is attacked in the United States, who's the first person they're going to call? It's not going to be you. You're going to be the first person that shows up, probably, but it's not going to be you that they call. And so when you show up, how much time are you going to spend trying to establish the channels of trust and communication so that we can start fixing the problem?
I would add that there's a need for exercises like Jack Voltaic, which Judy Esquivel and the ACI. Judy, can you stand up for a second and take the spotlight?
Wave.
There you
Wave.
go. Judy,
bow.
in collaboration with AECOM, Joel and company, are putting together, and this is a model that was done last year in New York City, and it's being done this coming year in Houston. And the idea is how do you pen test a city? And that sounds cool, and it's actually has a tabletop component and a live range component. But what's really interesting is it brings the right community together. So it's not really a power exercise for the sake of defending the grid. It's a city exercise, and there's an element, there's a deliberate attack that's meant to do a really specific strategic goal, to accomplish a strategic goal. And it's using as a vector the grid, or it's using as a vector the water system, or the financial system, or whatever that is. But by bringing those folks to the table, a lot of times, what we found out last year in New York City is like, this was the first time that these folks actually met each other. I was like, oh, so I would be working with you in a real emergency? Well, here's my business card. You don't want them to meet during a crisis. You want them to meet ahead of time. So this is an experiment ongoing by the ACI, and I'm a big believer in it. So kudos to you guys, and I think that's a model to follow across the nation.
It's the next session in this room, by the way.
Who's speaking on it?
So a real quick question for the audience. So how many of you guys are soldiers in the field, where you're actually firing weapons, boots on the ground, etc.?
Go Marines.
Hoorah.
Hoorah.
How many of you cyber people want to be the one that has bullets coming at them? Right?
Ooh, oh, definitely.
The Marine.
The Marine. So remember that just like like what you're doing in your jobs, that the field engineers, the people that are operating the systems, those are the ones that are getting the bullets when a nation state comes after them. They're the ones that are trying to keep the grid up. And they're not equipped, just like you're perhaps not equipped to have bullets fired at you. So you need to help them.
So we've run out of time, as we anticipated that we would. There's a couple of questions that I saw, either hands went up and then eventually went down. Feel free to find us all. All three of these gentlemen prefer to work nights, weekends, very late hours. Contact them day or night. But I did want to extend my gratitude and gratitude on behalf of CyCon, that each of you gets a reward for showing up today. All right, so feel free to come on up here. I'll hand them to you individually, but I wanted to take an opportunity to thank all of our panelists. Really appreciate your time, your expertise, your willingness to be very candid with us, and just your presence here at the conference. So thank you, one and all.
Good job.